Hello everyone, welcome to another one of my Leetcode videos. In this one, I'm doing Leetcode 509 Fibonacci number, and it's part of an effort that I want to make more dynamic programming videos so that any of you doing the Leetcode study plan on dynamic programming can benefit from these videos. So let's get right into it. So Leetcode 509 says that Fibonacci numbers are denoted by this equation. So the Fibonacci of 0 is 0, the Fibonacci of 1 is 1, and the Fibonacci of n is n minus 1 plus n minus 2 Fibonacci. So given n, we need to calculate the Fibonacci number. Now this is kind of dynamic programming because this is kind of the recurrence relation where you have the Fibonacci number defined as a function of previous Fibonacci numbers, right? So as long as in this case we have the previous two Fibonacci numbers, we can calculate the nth Fibonacci number. And n can be anywhere from 0 to 30, right? So first, let's take care of our basic cases where if it's either 0 or 1, right? So if n is less than 2, that means it's either 0 or 1, then we just return n, right? So if it's 0, we return 0. If it's 1, we return 1. Now the Fibonacci of n is n minus 1 plus n minus 2. In a typical dynamic programming, you have to store like an array or something to remember the past values. But in this case, since we only care about the past two, we can just say store those. So we can say int like n minus 2 Fibonacci, which initially will be 0, right? Because we'll start our n at 2. So for any n greater than equal to 2, we'll start our n minus 2 at 0, and our n minus 1 will be 1, right? Because that's the f of 1. So then we can have a for loop where we start n or I equals 2, I less than equal to n, I plus plus, right? So this will be our kind of loop to go all the way up to f of n. Now we know that int fibo of n is equal to basically the n minus 2 fibo plus n minus 1, right? That's our equation over here. Now that's the fibo of n. So basically if I is 2, we go n minus 2 plus n minus 1, so 0 plus 1. And then we need to adjust this, right? So the n minus 2 fibo now equals n minus 1 for the next round, right? Because in the next round, I will be like 3. So 3 minus 2 is actually 1 now. So we are kind of shifting. This is basically our second second previous value, and this is our previous value, right? So as n increases, the second previous value now becomes, which was in this iteration, the previous value, and our previous value actually becomes fibo n, which is the value we just computed, right? Because in the next iteration, I will be 3. So this fibo n for I equals 2 will be now our n minus 1. So we'll keep doing this until we hit n, right? So at the end of this loop, whatever the fibo n, this maybe is more accurately fibo I, right? Because we're calculating the ith Fibonacci number. But at the end of this loop, the fibo I will be equal to n because we're looping up to n. And we're going to be storing that in n minus 1, right? Because n minus 1 equals fibo n, or fibo I, this should be. So at the end of the loop, whatever is an n minus 1 will be our final answer, right? Because that's what we stored the last computation of the loop in. So let's run this code and see how this does. Oops, I made a typo over here. This is n minus 2 plus n minus 1. So let's run that again. All right, accepted. Let's submit. Perfect. So this beats 100% of runtime. I hope you enjoyed this video. I'll see you in the next one. Cheers.